All right, hello everybody. Welcome back to the section 4.7 video. And in this video, we're going to learn a couple methods to solving a homogeneous Cauchy or Euler differential equation. Okay, so consider the Cauchy-Euler homogeneous differential equation. It's homogeneous because we don't have a free-floating x component, so this makes this homogeneous. Homogeneous Cauchy Euler differential equation. So how would we solve a homogeneous Cauchy Euler equation? So it's a bit similar to constant coefficient differential equation that we learned in section 4.3. But let's go ahead and see how we come up with this exact method. Okay, so how would we solve this? Let's take a guess and say, y equals x to the m is the solution. Okay, trust me on that. And so let's see how this plays out. So I want to use y equals x to the m, and I want to plug this into my differential equation. So I need a first and a second derivative. Okay, so the first derivative using the power rule, bring down the m, we have m times x to the m minus 1. And then a second derivative would be m times m minus 1, x to the m minus 2. Okay, so we take our derivatives and then we plug in to our differential equation. Okay, so we plug this in, we get ax squared, oops, we get ax squared times m minus 1, x to the m minus 2, plus, let me bring this down here, give myself more room, m minus 2 plus bx times mx to the m minus 1 plus c times x to the m equals 0. Okay, so let's go ahead and start simplifying this down a bit. Let's distribute in our ax squared, our bx, and our c. Okay, so what do we get? We get a, the x squared would go towards the x to the m minus 2. So what this ends up being is am times m minus 1, x to the m minus 2. And then I'm going to take this an extra step. This would be like plus 2 because of that x squared. Okay, so same thing, this would be b m x to the m minus 1, and then that plus 1 would be because of that x distributing, and this would be plus c x to the m equals 0. Okay, so the exponents 2 and 1 cancel out, so what I'm left with is am times m minus 1 x to the m plus bm x to the m plus c x to the m equals 0. All right, so what do all these terms have in common? They have an x to the m in common. So what I'm going to do is factor out an x to the m. So this would be am times m minus 1 plus bm plus c, and I'm factoring out an x to the m. So here I'll say factor out x to the m. All right, and this all equals 0. And what can I do? Let's go ahead and distribute in this am into m minus 1. And so what I'm left with is am squared minus am plus bm plus c all times x to the m equals 0. Okay, so what do AM and BM have in common? They have an M in common. So what I'll have is AM squared plus B minus AM plus C all times X to the M equals 0. And so this right here, my AM squared plus B minus A times M plus C is my auxiliary equation. And so we're going to use this auxiliary equation to solve a homogeneous Cauchy-Euler differential equation. So the way this works is that, therefore, y equals x to the m is a solution to the Cauchy-Euler differential equation when m is a solution of the auxiliary equation. Okay, so that's what this statement means. Okay, so that's the setup. That's the auxiliary equation. So that's it for this video. Thank you for watching. In the next video, we're going to take a look at the different three cases. Okay, but I'll see you in the next one. Take care.